Starburst Galaxy is a data lake analytics platform built on the Trino open source SQL query engine. But what is a query engine and what problems is it designed to solve? How do you use SQL to query a data lake, and how does Starburst Galaxy help facilitate this? You've come to the right place. This video is here to help answer all of those questions and show how Starburst Galaxy makes it easy to query data lakes, making them the center of gravity of your data strategy. First, let's get the definitions out of the way. SQL, SQL, is an acronym that stands for Structured Query Language. It's not a new language, and that's part of its advantage. It was developed in the 1970s as a way of querying relational databases, and since then has expanded its reach deeper and deeper into the data space. These days, using a modern platform like Starburst Galaxy, you can query databases, data warehouses, traditional data lakes using Hive, and modern data lakes and data lakehouses using modern table formats like Iceberg, Delta Lake, or Hudi. More on those technologies in a minute. But let's back up a step. SQL is a structured query language, but what is a query? It's one of those questions that you think you might know the answer to, but it's worth digging deeper. In essence, you should think of a query as a question that we ask of a data set. As you might imagine, queries come in all shapes and sizes, and the kinds of data sets involved vary considerably. This is where SQL comes in. Although there are many ways to write queries, SQL is a dominant language within the data science community. The relative ease with which SQL breaks down problems is a big part of its success. For instance, imagine that you work at a company that keeps track of its customers to target marketing campaigns. You have a table called customer info that's set up in a traditional relational database structured with columns and rows. You may have lots of different kinds of data in there, but let's say that you have 4 attributes to start. First name, last name, city, and activity status, whether they've been shopping in the last 6 months, let's say. Because this information relates to the attributes held by each customer, it's going to be captured in the columns. Then, each time a new customer completes a transaction, a new record is created in the customer info table, represented by rows. Let's say that this database is very large and goes on with names, cities, and activity statuses for many customers. Let's say that you want to select the first 10 entries in the database to see what kind of data you have. This is the first example of a query, a question asked about the data set. How do you start? Using SQL, this is relatively easy. The syntax for a simple query can almost be read like normal English. We start by saying what we want to do. In this case, we want to select a subset of the data and return it to look at it. Since this is a programming language, we can't just respond in plain English. We need to know the specific syntax of the language. In this case, SQL. Again, SQL makes it easy. The syntax for selecting a set of records is select. Let's put that down here and keep going with the query. Now, there are a few different ways to do this, but one common way is to select everything and then refine that using a limit. To do this, the syntax is a bit more technical. SQL's term for everything is just star. Let's put that down in our query and continue going. Next, we need to say what we're selecting the data from. We already know part of this, customer info, but customer info is a table. This is where a new concept comes in from Starburst Galaxy that's going to help us. Catalog, schema, and table. These 3 terms are extremely important in Starburst Galaxy as a way of keeping track of information of all sorts, whether it's a simple table or something less structured like a data lake. Let's look at them one by one. Catalogs refer to the data source where the data resides. This can be anything from a traditional relational database, a data warehouse, or a modern data lake. It's the first piece of our puzzle, and in this hypothetical example, let's imagine that our database tracks transactions of various sorts, not just customer data, and that the name of this database is transaction. In reality, this would be the name of a system set up well in advance of our query. For now, let's put transaction down in our query where it belongs. Next, you've got schema. A schema is a way of dividing the data inside a catalog into units that describe data of a similar structure. Schemas are defined by data architects when they set up a data source, and depending on the technology used, it can either be defined before the data is added or after. In this example, the schema in question is called customer. Inside it, we can imagine lots of other tables beyond the one that we already know about, but that's a story for another time. For now, let's add the customer schema to our SQL query. Last part. This is the easiest one, the table. We already know it, and we already know its name, customer_info. Let's put that down in the SQL query. Okay, now it's the last step. We need to limit the query so that it doesn't return everything. As it stands right now, it can make for a very large amount of data, but we're only looking to get the first 10 entries for now as a test. The syntax for this is easy, and the command you need is called limit, followed by the number that you want to return, in our case, 10. Let's put that down into the SQL query. And that's it. Let's read over the query to see if we understand it. Select all entries from the catalog known as transaction, in the schema known as customer, and the table known as customer_info, and limit the data returned to just the first 10 entries. Okay, that makes sense. And what happens now? This is when the story shifts to Starburst Galaxy and Trino. When you put a query into SQL in Starburst Galaxy, several things happen. First, the query is broken down into its component pieces and distributed across the computing cluster set up in Galaxy. There are many different types of clusters and many different configurations, and Starburst Academy has lots of educational resources if you want to understand these configurations in more depth. For now, all you need to know is that your SQL is broken down by something called a coordinator and distributed to a number of workers. The workers then execute their workload and send the results back to the coordinator, who sends the completed results to the user. Depending on the complexity of the query, there might have been many workers and many stages, or just one. For a simple query like the example in this video, we could get by with a small number of workers. More complex queries might involve many workers. And this is a large part of Starburst Galaxy's success. It allows you to scale the resources that you need to address different questions in different moments. The process of breaking down a query with a coordinator and worker is called massively parallel processing, and the technology that powers it in Starburst Galaxy is the open source query engine known as Trino. Trino's underlying architecture is a big part of what makes the system work, but whereas Trino is a complex manual system designed for a highly technical audience, Starburst Galaxy gets the same results in an easier and more user-friendly way, adding lots of additional features along the way. This is why we talk about Starburst Galaxy as an analytics platform. And although it's designed to work on almost any data source, it works best of all on modern data lakes, making use of cloud object storage. Data lakes provide a few benefits, so let's go through them one by one. First, the data inside them can be structured, semi-structured, or unstructured. This is important because although our example shows a classic case of structured data set in a table, a lot of the data that organizations use is not structured at all. It comes from things like websites and app click data. And this data is perfectly suited to the data lake, where it can be added in an unstructured form and then transformed and structured later through a process known as schema on read. The second reason is not technical but no less important. Compared to traditional technologies, cloud object storage is very inexpensive. There are a few reasons for this that range from the technology itself to the economies of scale by the cloud object operators, but the end result is a massive savings for data lakes over data warehouses or databases. The last reason is efficiency. In the past, traditional data lakes based on Hive performed badly against other technologies. In recent years, modern data lakes and data lakehouses have taken hold, making use of modern table formats like Iceberg, Delta Lake, and Hudi. These formats handle metadata in better ways than Hive, leading to better performance and a host of new features like time travel and schema evolution. With the openness of Iceberg, data lakes have essentially entered a new phase of their storage, performance, and cost-benefit analysis, making for an easy choice for many organizations. Starburst Galaxy brings all of this together. It lets us ask the questions about data that we want to ask and lets us do it all on a modern data lake that helps us save money along the way. That's a compelling proposition for anyone who wants their data to provide insights and balance the advantage against the material costs associated with big data. Big data without the big price tag.